So in this section, we're going to look at a method of integration called integration by parts. And this method is used to integrate a product of two terms. So in this example, we've got the product of x and cos x. So I'm not going to go through how to derive the formula, but you can derive this formula from the product rule. So in order to use this formula, we need to define two variables, u and v. And the formula also has in it du by dx and dv by dx. So in order to use this formula, what we're going to try and do is we're going to try and make the integral that we're trying to find equal to the left-hand side of this formula. So you can see that we want u times by dv by dx. So we want these two terms, when we multiply them together, to be x cos x. So you can see that we could either have u is equal to x and dv by dx is equal to cos x, or we could have them the other way around. U could be cos x and dv by dx could be x. So the key to realise which way around they need to go is to realise that in order for this formula to help us, we need to be able to integrate this term here. We need to be able to integrate v times by du by dx. So what we're going to do is we're going to choose u such that when we differentiate u, we get something simpler, which is easier to integrate. So if you look at our options, either x or cos x, when we differentiate x, it's going to get simpler. So if we put x there and cos x there, we should be able to integrate v times by du by dx, because du by dx in this case is going to be 1. So let's just check that we can integrate this green integral. So we know that dv by dx needs to be cos x. So to find v, we're going to do the opposite of differentiation, which is integration. So the integral of cos x is sin x. And you can just check when you differentiate sin x, you do get cos x. So the key thing to check before you use this formula is that we can integrate v times by du by dx. So in this case, v times by du by dx will just be sin x, which we know how to integrate. So that means we've got the order of u and dv by dx the correct way around. If you couldn't integrate v times by du by dx, then you would know that you could try swapping the order of u and dv by dx around and see if that works. Another way of deciding which is going to be u and which is going to be dv by dx is to use an acronym called LATE. And this is just a bit of a trick to help you out. You might see it online. L stands for logs, A stands for algebra. By algebra, what we mean is polynomials or powers of x. So let's just put powers of x here. T is trigonometry and E is exponential. So by that we mean e to the power of x, for example, or e to the power of some function of x. So the way that we're going to use LATE is we're going to have a look at what we're integrating in our question. So we've got x and cos x. So x is algebra and cos x is trig. So we've got to see which letter comes first in LATE out of algebra and trig. Well, A comes first in LATE before trigonometry. So because A comes first, we're going to let our algebra term be u, and our algebra term was x. And then because T comes second in LATE, in the letter LATE, in the word LATE, trigonometry is going to be dv by dx. So we can use this formula now. So the left-hand side of the formula is the integral of x cos x, which is what we're trying to find. And the right-hand side is u times v, so x sin x, minus the integral of v du by dx. So v du by dx is just sin x times 1, which is just sin x. And remember, this works because when we integrate these two, it's a simpler integral than we were faced with in the question. So now we can integrate this. We just got to be really careful with the negatives. So I'm going to leave that negative there at the front, and then I'm going to put in a bracket, what is the integral of sine x? The integral of sine x is minus cos x. It's really easy to accidentally forget this minus here and get confused with the minus that comes from integrating sine. And then finally, we can just neaten this up a little bit by expanding this bracket and adding on the constant of integration. So that's our integral.